Okay, what we have here is two coils, P and Q. Describe what is seen to the reading of G. So when the switch is closed, what will happen? When the switch is closed, a current will flow like this, and that makes this become a magnet, doesn't it? Now when that happens, it cuts through this coil, which makes a voltage. So a voltage is produced, and then this thing will move. So we can say that, can't we? The pointer on G moves to one side. But because this is a direct current, this current never changes. So now this field never changes. And if the field doesn't change, then there's no more cutting. It stops cutting. Which means that no voltage is induced, and this goes back to zero, moves to one side, and then returns to zero. Doesn't say why, it just says describe what is seen. But the reason why is that for G to read a voltage, there must be a changing magnetic field. This is a direct current. Because the current in P, this one, is direct current, the magnetic field does not change. So there's no voltage. Okay, that's Faraday's law again. So now what happens as switch S is opened again? Well, when switch S opens, the current stops. When switch S opens, the current stops. That means that this field disappears, goes away. And if it goes away, it cuts again through this coil. And if it cuts through this coil, the pointer moves. So the pointer will move again. But it will move the other way. Will move to the other side, and then return to zero. Okay. Now I'll just go through why again, because you need to understand why. When the switch is opened, when S opens, current stops. So magnetic field goes away. And when the magnetic field goes away, the coil Q is cut again. So a voltage is induced. Okay. So this is the answer, but this is just to help you to understand what's going on. A soft iron bar as long as the combined lengths of P and Q is placed inside P and Q. So what they're doing is they're putting in a big, long iron bar in here. Okay. Now I showed you this because if you remember in the lessons, we had two coils of wire like this. and we did something, and then later I put in an iron core, and it made the voltage much bigger. So state what difference this makes to as observed on G. The pointer moves further. The pointer will go much further because this iron core adds magnetic field. The bar is removed and the battery is changed to one with a smaller EMF. State what difference this makes to G as switch S is closed. Well, if this is smaller, then this one will be smaller. Okay, so the pointer moves less. Okay, that's all we need to say. All right.